Today's first session is on exploratory and confirmatory factor analysis on SPSS and AMOS. And our guest speaker is Dr. Mohd Nasir. Dr. Mohd Nasir works as an assistant professor in the Mittal School of Business, LP University, Punjab. After doing his MBA, he earned his PhD from University of Allahabad. Dr. Nasir is in Scopus, SSCI, and ABDC Index journals. He has also presented papers in international and national conferences that include National Institute of Technology Hamirpur, All India Commerce Conference, etc. Lastly, I would like to thank our esteemed organizers of the FDP for providing me this opportunity to be the face of you all for introducing the speaker of this session. On behalf of you all and on behalf of Department of Management, SMBS, Jamia, Hamdard, in collaboration with AICTE, ATAL, I, Jaya Madhurima, hand over the reins to Dr. Mohd Nasir, wishing you all a very thoughtful, provoking session. Thank you very much. Over to you, sir.
Thank you, ma'am. Am I audible? Dr. Azad, can you please confirm that I'm audible at your end clearly?
Yes, you are.
Yeah, thank you, sir. So thanks, ma'am, for a brief introduction. And with this note, I'm just uh, just about to begin my session with as per the schedule, exploratory factor analysis using SPSS, and then we will go for confirmatory analysis using AMOS. I will take few seconds to share my screen. Just please confirm, is it visible to you all?
Not yet. Yes, it is visible.
Okay, so Dr. Jamshed, can I proceed with the session?
Yes, sir, please.
Okay, thank you so much. So we talks about the factor analysis. Basically, it is one of the we have find and that in number of literature, EFAs, CFAs are there, and it is one of the most popular technique that we use in the social sciences. Actually, when we talk about a factor analysis, the exploratory factor analysis, and we talk about confirmatory factor analysis majorly. So, but this EFA, the exploratory factor analysis that we are using in the present time, and it has been in practice since decade. But the emergence of this itself, it is from the need of the researcher field in the field of psychology itself. Then later on, it's being highly used in the terms of social sciences, and now we have seen that over the time it has been one of the major analysis that we have been using in social sciences along with finance and other also, with including psychology. So why this exploratory factor analysis becomes so much this popular, becomes so much important, as it has been a exploratory factor analysis was this incepted with an major idea for how to reduce data. It's basically developed for the purpose of data reduction and summarization technique. So when earlier, suppose when we have more than 30 or 35 or 40 variables that when we are trying to measuring something, so it's quite it's quite obvious that these 30 or 40 this statement, or you may say a variable we are using to measure something, that probably will be having a number of the correlation between these variable will definitely be high. So that was the problem that actually this social science student were facing while going through the regression and other analysis. And because of this high level of correlation, multicollinearity problem was existing. So we will discuss all these things in detail. It was just a brief background of this EFA that we are going to talk about in this session. So in this ad, we know that it is a data reduction and summarization technique. So the basic idea behind this EFA is how we can reduce a number of these variables into some meaningful for dimensions that we consider as a representation on behalf of that. Let's take an example. We have 40 variables, and we are trying to know something. We are trying to measure something, and for that 40 variables we have taken, and we have taken a data, and we have taken a responses of, and now the problem is there that when we are going with using with in the regression part or other analysis, now the multi-collinearity problem it's going to be happen because of high correlation. So that's why data reduction has become very important. So this exploratory factor analysis, we can condense, we can get a minimum number of dimensions. We also call it the factors in terms of exploratory factor analysis. And that for three, let's say we have for 40 variables, these 40 variables, and we have used, and with the help of exploratory factor analysis, we may get 4 or 5 these factors that act as a representation of these 4 or 5 these 30 or 40 variables. And now this these variables are presumed that they are not very much related or somewhat related to each other. Okay, so we will discuss all these. So next, this moving ahead, so it examines the interrelationship among a large number of variables and then attempt to explain them in terms of their, yeah, as I told you, that this exploratory factor analysis, it helps to what to do. It's in the interrelationship of the due to the interrelationship among a large number of variables, it examines that relationship, but with the help of some underlying dimensions that act as a representative of that 40 to 50 variables, or you may say item, sometimes scale item it is called, sometimes it is called in case of when we're talking about in terms of scale, like a type of scale, then it we talk about times these items, some called as indicators, like that. So these underlying dimensions are referred as factors. So these 4 to 5 that we will get from this exploratory factor analysis will be considered as, or will be called as commonly factors. These factors represent now whatever the earlier and original 40 to 50 variables were there. So it is an interdependence technique. Yes, it is an interdependent technique, because in this we are not considering that which one is independent and which one is dependent. We are taking together in terms of CFA, and we are trying to club that and form some meaningful construct that act as a representative or give a better representation on behalf of that. So it may be, just for example, I have quoted one example that measuring mobile manufactured image by asking responded. So if there is a one mobile manufacturer, and he just want to, before going with the launch of mobile, he may be interested in knowing about mobile manufacturer image and its different aspect related to the mobile. So he may come up with number of statement that he wish to ask from the respondent, that it may help in taking number of identification of different aspect that may be related to that, that may be important. So it may be related to number of variable independent also, and number of aspect. Let's say 20 or 30 questions are there, but right now it's not clear that which one is considered to be independent or dependent, nothing, just to take the opinion, just to take the information. So due to, after getting this, and when we left with 25-30 this statement, and which may, as we know that Likert, in types of Likert scale, some repetitive questions do there, they are very much similar in that cases. So more of the thing is that the idea that EFA that we should employ, and with this help we can get some meaningful dimensions, when some meaningful factors should be come out. We will see in the later cases that how this convergence, and we talk about convergence validity also, then we will talk in detail. So the before this moving ahead with this exploratory factor analysis and detailed discussion, one thing is, at this point, that researchers and writers also have suggested and advocated the use of EFA and CFA. So now we are stick with EFA as the exploratory factor analysis. So basically, the main aim, the main idea behind this application of this exploratory factor analysis to explore.
Sir, slides move नहीं हो रहे हैं.
Is it now?
Only
No,
first slide
no.
isn't showing in slides.
I think Dr. Nasir hasn't started with the slides. He's just introducing the topic, I think.
Yes, I introduced in the recent, just few seconds back, I have just switched to second slide. Is it switched in you? It is visible my second slide or?
No, 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 no. It's the first slide only.
Okay. Now I think,
Why to use EFA?
yeah. Yeah. Now I think it's okay. Are you able to see this why to use EFA slide?
Yes, yes, yes.
Okay. So why to use EFA? The basic question that one may ask. The one thing is to identify underlying dimensions or factors that explain the correlation among a set of variables. So one thing is also important that when there is no correlation or very less, we may say very low correlation between the set of variables, then it is very, then actually and logically we should not go for EFA. Okay, because in EFA, when due to high correlation or only then when we have some statement, when we have item, it gets clubbed together and form some groups. Then to identify a new smaller set of uncorrelated variables, yes, as I just told you in the introduction also, that the major aim to find out this some uncorrelated variables to replace the original set of correlated variables that we call is a factor. Second thing is behind this exploratory factor analysis, that we believe that the application of this EFA we are using when we are very much the topic is new, where the scale is not there, or maybe previous study is not there or very limited. So the is here if a researcher wish to just develop a scale, or the topic is new and he's looking for that development of the some scale new for measurement, so the exploratory factor analysis should be preferred, and it helps to get the new identified dimensions. So basically, the application of EFA when the studies are very much limited, and or you may say a new topic is there, or researcher doesn't have any item or scale, then we should go for this EFA. So, like for example, 15 variables can be turned into 3 factors, which may be later used as independent in regression also. Now, why, as I just told you that the last point is to identify a new smaller set of salient variables. Yes, larger subsequent multivariate analysis. As in the beginning, I just said the basic reason and the basic thing behind this, just to get uncorrelated factors so that the multicollinearity can be avoided. So now I hope now I switch to next slide. I hope it's fine now.
Yeah, it's fine.
Yes,
Dr. Nasir, could
Yes.
you please put on a reading mode so that the PPT is much more visible? The reading mode in the, before that. This one, yes, click it. Thank you.
Okay, thank you. So there are certain assumptions that we need to follow also with regard to this exploratory factor analysis. So the multiple variables that we are considering that can be measured at continuous scales. Relationship among the variables tend to be linear. So linear relationship should be there between the variables. Adequate sample required. Yes, sample which is very important, and we also check it with the help of one measure is there when we just execute that. So with the help of KMO, we can just check this issue, and data should be suitable. For deduction, need to have adequate correlation. Just again, the correlation also because in the beginning I just told you when there is no correlation between the items, then how this similar or correlated, highly correlated items or variables are going to form this dimension. Then exploration of the factor may be a challenge in that case. And ideally, if there is no correlation or very low correlation is there, so we should avoid using this EFA. So beside this, we can also check for absence of significant outlier, that outliers is there, or is there any outlier which is significant, so we also check it. Homogeneity of samples, so the samples that we are working on, the should be homogeneous in nature, and Assumption of independence of observation means all the observation, all the items or variables are should be interdependence. This means correlation should be there. So what key statistics in EFA we considered? So communality, one important thing is communality, and which is this: the amount of variance of variable shared with all others being considered. This is also the proportion of variance by the common factor. See, communality is something as its amount of variance of variable shared. So let's say there is one variable. So how these one variables, this particular one variable will be loaded, definitely will be loaded. We will I also go through the, when we go to the component matrix, we will see this particular variable gets loaded in number of factors. So the number of factors, the square root, the sum of square root of each loadings statement loading in each of the factors is called as the communality. So this communality, the researcher and the various accumulation has recommended that it should be above 0.5. Second is the eigenvalue. So the eigenvalue, it's within the total variance explained by each factor. So now we will, if we are considering the row point where each variable is loaded in each of the factors, so then the calculation, the square root of these each loading will be considered, the sum of that consider the communality. But when we are very much specific, we are talking about each single factor. So whatever the factors variables are there in the factors, the summation of that square root of that each loading will be part of that considered as the eigenvalue. So factor load is just simply a correlation that represent of each variables to the respective factor. So what this factor matrix, so there is also called a factor matrix, contain the factor loading of all the variables of all the factor extracted. Then factor score. So factor score is something that we can use it, and it act as an independent variable that we may use it later on for another analysis like regression. Then percentage of variance. So the percentage of variance is that total variance, that whatever the how much the total variance is being explained by the identified factor, that is the variance. So what are the steps in analysis? So step one start with computation of correlation matrix of all the variables computed. Then we go for factor extraction. Then vector rotation we may also consider, and final decision we will taking about the underlying factors. So just moving ahead, so we talk about correlation matrix. So generation of correlation matrix for all the variables. Okay, so whatever the variables are there, there would be a correlation matrix, and all these variables, they along with their loadings value, their collision with the respective factors will be highlighted in the help of this correlation matrix. So low correlation among the variables, as I said in the beginning also, that if the correlation is very much low, so they are unlikely to going to share that common factor. If we have some common statement 1, 3, 5, 7, 9, if these have high correlation among themselves, yeah, definitely they will share the same or common factors, and rest not. Rest will be go to the next factor. So correlation coefficient greater than that we call it a factor loading basically. So basically in most of the cases we also have seen that if you go to the number of literature available, here mostly this loading value above 0.4 generally considered to be a part, whatever the variables are there with the value above 0.4 we can consider it, and we can keep it in the factors. But there are also other researchers, they have in paper they have reported that 0.3, if we have a limited set of variables, and then we can keep 0.3 also, at least if we just square this to at least 10%, around it's make a 9%, because r square will be 9%, so around 10% of the, if it is able to contribute, then we can also consider it. But it's up to you. If you have a sufficient number of statement, and if all the other variables they have loaded with a significant value, then you may drop that. So Bartlett test of sphericity. So Bartlett test of sphericity, when we just run the EFA also, we will go through it, this BTS also. So The BTS also, the basically, as in the beginning also I have just said that it assumes that the correlation is there. Correlation is there between these variables, and this can be checked with the help of Bartlett test of sphericity. And if it is significant, means if it is significant, its value is less than 0.005, or in case of as per the significance level, we consider that it is less than 0.05, then we can see that significant correlation is significant. Then what we presume that it has to be there, it is there, and the null hypothesis in this case should be rejected. So with this BTS, it confirmed that the correlation that the requirement of this exploratory factor analysis is there, that the correlation should be there, the items should be correlated. It can be satisfied with this BTS, and null hypothesis, yeah, definitely will get, it has to be rejected in this case. So another KMO, Kaiser-Meyer-Olkin value, it is again talks about sample adequacy, and whether our sample is sufficient enough to just go for factor analysis or no. So the greater the value and nearer the value to the one indicates sizable, you have a adequate sample adequacy. However, minimum 5 is the cutoff, below which it is not acceptable. However, some have recommended for 0.6 also, and but if you are getting a value near to the 1, 7, 8, 9, so it's good. So next we talk about factor extraction. Factor extraction, actually now which method we are employing? Majorly principal component method is a widely used method in this extraction method. So initially it can be made here about the number of factor underlying a set of measured variable. So what number of factors do you want to consider? It can be rely on few other things also, because we may fix also in the factors as per our requirement in the EFA. But one can be only do this when a strong literature, or when that person have a expertise. That person is expertise enough, and he should have a valid reason that why I'm just wanted to extract this 3 or 4. Okay, it can be help of eigenvalue can be considered, and other parameters also there. On the basis of that, we can decide in that case. So estimation or estimates of initial factors are obtained using PCA and principal. So basically two factor analysis method mostly employed: this principal component analysis and principal axis factoring method, which is also at common factor method. So PCA is the most common analysis we found, and it is widely used in extraction of these factors. So when we talk about PCA, so it is approach that consider total variance. The basic difference between this PCA and this common factor, it is just that in PCA, it considered the total variance are available in the data set, while in the case of common factor, it's only talks about whatever the variance which are shared commonly by the factors. So it ignores the total aspect. So that's why most of the researcher, they prefer to go for this PCA. And also when we have a larger sample size, and when we are getting the community value above 0.6, so we may also get a similar type of result if we are using any of this method. So, but the basic difference is this, that it works on total variance and it's shared a common variance of interest. So when principal component analysis, when the basic objectives, why we are using this EFA, that we must have a small number of variables that shared a maximum number of variance in spite of just using that 30 or 40 variables. So in that case, the PCA is very useful approach. So as I just said, that when we have a number of variables more than 30, and when we are getting the commonalities exceed 0.60 for most of the variables, so most of the cases, the result will be very much same. So factor extraction determination. So as I said, that factor determination, the basic and majorly used method is based on the eigenvalue. By default, also SPSS use this eigenvalue concept, and just that SPSS provide you number of factors before you, and you may take the as per the required factors. So when may just beside this eigenvalue, there is something called a script plot also. You may just, with the help of a script plot, you can just decide that how much, ideally how much factors you can keep, and that will be sufficiently enough to explain the for your this data set. Then percentage of variance, that if you are, because the researchers are mostly just advocates that in terms of social science, if your total variance are if the your this extracted factors, if they are just explaining 60% of your this total variance, then it is sufficient, you can keep up to that. And if you are getting for maximum, it's wonderful. So with the help of this, you can also detect that which number of factors you may have. Suppose you have got 6 to 8 factors, and it is somewhere around 80% explaining. But if you're trying to, okay, that's 80%, let's check and go for, you are fixing the factor rotation and you are just limited to 6. You are keeping that to up to 6. And if that 6 factors, they are from 80, they are just definitely, when the factors, number of factors are going to reduce, definitely your total variance also get reduced. But if from 80, if it is going to 70, and if that the factors, if 5 factors are explaining this much, or 6 factor explain this much, you can also keep that 6 or 5 factors as compared to the 8 factors, or you may also go with the previous one. But as we are following this, that we have a minimum number of explaining maximum, so with this approach of parsimony, we can go with this also. So there is one thing more based on split half reliability, means it's something that where we have when we have a sufficient number of samples, so we are just dividing the complete sample into 2 parts, and each sample, on a sample we are doing this EFA. If we are getting the loadings value almost similar, so we are very much in the right direction, and we can go in the same approach with the selection of these factors. So there is something called as factor rotation. So factor rotation, when we talk about, so basically when we going through, and when we are trying to when we are trying to get the factors without rotation, definitely the factors will be there. But we have seen number of times that when we are not using, actually why we are using rotation, it's helping you to get more distributed form of variables in these factors. What happens some of the times, it's happened when we have more variables, so without rotation, number of variables get loaded in one of the variables, or maybe less with the in any of the other, it may be loaded with very less number of variables. So the distribution of these variables, is not properly, is not properly done without the rotation, and these factors and along with the variables, they seems to be clumsy, and they are not, multiple cross loading may be fine in that case. So it is advisable when you are facing this type of issue, when someone is struggling that multiple correlation, these multi cross loadings are there, number of cross loadings are there, and it's generally happen when you have a large number of variables. So in that case, factor rotation is recommended. So with these factors rotated to make it more meaningful and easier to interpret, as I said, if you number of variables are more, and if these things are, it's your table, this component table looks a little bit clumsy, so it's a little bit difficult, and it would not be easier to interpret it also. And different rotation methods, yes, number of rotation methods are there. Basically we go for or this varimax rotation, that is one of the most preferred one. And two broad categories are orthogonal and oblique rotation. So basically we go for orthogonal, in which varimax rotation we use. Then with regard to this, the final decisions about the number of factors to choose is the number of factors for rotation, that is most interpretable. So the final decision that we take, as I have also shown you, that number of factors can be there, on the basis of which we can select that, okay, this much factor is sufficient, which this much factor is sufficient, whether we can give 4, 5, 6, is depend. Then to identify factors, group variables that have large loading for the same factors. So we are interested as in the beginning the basic purpose to identify our factors and the group the variables. Grouping the variables means sharing the common factors in which the become this correlation and are higher and the loadings which are loaded with the higher values. That is, now whatever the factor, as it is the exploratory factor analysis, it assumes that it is new. So now how to interpret the factors, what names you will be given that factors. It's according to the meaning of the variables. Means you might be having a let's say 40 or 30 variables with you, and you have run an exploratory factor analysis, and you are left with 4 to 5 factors. Now, if 5 to 6 statements are there in factor 1 and 3 to 4 statements are in factor 2, then how you are going to name them? So whatever the items, whatever the variables are loaded, you after going through the statements, after going through the similar type of statement that are loaded on the factor, you it will help to interpret that particular factor, that how actually it's what it means, what its what's nature or what type of this similar type of variables are loaded in the same factor. Then calculate alpha for the reliability. Yes, reliable deal to the reliability issues. We go for this Cronbach alpha, and reliability also nowadays this omega. That omega also used by given by Hayes and Counts 2020. Is also in practice. So now the name the scale and construct. So after you have identified the factor, the factors have been identified. Now the next is task is to the scale that you have identified. You, if you are wish to give some scales, like we have servo call, serve of all these scales for big scale, number of scales are there. So you can go and give the name of some scale and construct that you have identified. The name or the identifier, the name also needs to be given. Some names are the that construct, that the identified construct need to be given, and that would not be given blindly. That definitely would be depend upon the similar types, the nature of what different statements or variables they are loaded on that respective factor, considering that theme, that actually what these variables trying to measure, these what type of question it has been asked. By keeping that theme, that the things that you want to measure, that want to ask, you can just interpret your construct in that way. So with this, you will decide your variables, your construct, and your scale. So reporting. When we talk about reporting, that is the important thing. And sometimes when we are done with the exploration, we have the variables, but somewhere we are unable to, somewhere we are unable to, unable to report. And number of times we have seen that few papers we have seen that it gets rejected because of the key things that we need to report in the paper, it's missing. And due to which we get number of comments also, and student they more focused on factors, and beside this also discussing about the key statistic associated with this exploratory factor analysis. At the end, I will also share the some of the important research papers related to these topics, and I will mail it to Dr. Asad also. He can share with you all, and it may help you those who want to know more about in detail how to report and all these things. So reporting, basically theoretical rationale for EFA means its contribution in terms of that you have trying to attempted to develop a new scale. You are attempted to a new scale, or maybe you are very much focused toward that some key factors should be explored like that. So in that case, reporting is become very much important, and you have to also justify your theoretical rationale. Detailed description, subjects and item included. Yes, and we will see that in descriptive statistics also there, that mean, median, and the key is descriptive stats we also focus in that. Correlation matrix, yes, it is one of the important things from which only you can able to calculate your eigenvalue, from you are also able to calculate your communality. Method, yes, method use, which type of method a researcher has employed getting these factors explored. Okay, then communality, the values of the communality, that as we have said, the limited the threshold level is 0.5. Factor extraction method, which rotation, or it is whether we have used a rotation or not. So these all things we should report. And along with factors, that what number of factors you have identified, and each factors what different variables you have identified, along with their loading, along with their factors loading it also. And it should be, that is the that is the key things that you should report in EFA. It should be there, that what different variables are there in that particular EFA, along with their factor loadings. And variance explained, yes, no doubt, what we are doing and how much the factor selection, 4 or 5 or 6, how much the total variances the factor, these identified factors actually explaining, that is of also a great interest. So this is how we can do these things. So now quickly I'm just going to this open a data file, so that whatever we have discussed theoretically so far, we can also have a look of that. It may take a few seconds to open that SPSS file.
Dr. Nasir, can you share the data set so that participants can just work out with you?
Okay, okay, just wait a second.
You may WhatsApp on my number. We will share.
Okay, sir. Okay. Just give me a few seconds. Just wait for a second. Yes, Dr. Asad, I have made the data set. Could you please check it?
Yeah, I'll just check it. Participants, you have been mailed the data set. So please download it from there. You can download from the WhatsApp also, wherever you find it convenient. So, Dr. Nasir, give them say 2 more minutes so
No issue, sir.
that they are ready with the data.
No issue. Could you please confirm that my screen with the data view is available at your end?
No, not now. Because it is dark.
Okay, let me. I hope not visible.
Yeah, your screen is visible, Dr. Nasir, but the thing is, the portion actually which where should can you present that CFA or EFA, whatever you just want? Yeah, now it's fine.
Yeah, it takes sometimes few seconds to
Okay.
visible at the other end.
In the meanwhile, you can just open the that EFA file, I think.
Okay, so I just wanted to execute and show once. Okay, my data set is visible.
No, not now.
Not
Only
now.
you are visible.
Okay.
Yeah, it's fine now, Dr. Nasir.
Okay, thanks.
So participants, I hope you all are ready with this data set, EFA data set. Please respond to Dr. Nasir so that he can continue.
Yes, sir.
Okay, thanks. So in your data set, there might be number of things are there in this data set, although number of others variables are also there. But we are very much concerned right now with this up to 30 D6, A1 to D6, 30 variables are there. We are very much focused with this. Okay. So right now we are just suppose we it's just a fictitious data for just practicing and to understand how we are going to run this and how we are going to report what things we need to consider. We will try to understand all these things here. So let's say 30 there are 30 statements were there, and something it was asking. If you go to the label view, you may asking it's something related to the after sales service. Sometimes it's talking about bill clearance, and sometimes talking about queues. Somewhere it's talking about a staff at the authorized service center, and sometimes it's also including the waiting area. It is there, and likelihood level also is there with regard to number of maintenance contract, and all these things and are related, and it is very much all this related to this after sales service. Okay. So right now we are considering that 30 statements were there, we have inserted, and we have just made the entry for our data set. Now our data set is ready. Now with this to go for this exploratory factor analysis, as we are aware that we go with the dimension reduction factor. And here you may be I hope my screen is also you are able to view the changes that what I am making at my end.
Yes, sir.
Okay, thank you. So right now, what we can do, you can just need to select these variables. This means 30. I'm just considering 30, A1 to D6 in here in this variable box. So you can do one by one also, and you can just go and using shift and downward arrow, you can select up to D4, 5, 6, and in one go you can select it. So right now we have selected all these 30 variables, and now if you, as I just told you, you can go for descriptive also, but is here something KMO and Bartlett test of sphericity is given to ensure the sample adequacy and to check this Bartlett test of sphericity significance. We will go with it, continue. And in this extraction right now PCI is there, so by default you can see that principal component is there, so we can go with principal component. And one thing is very interesting is there, since script plot. So I just wanted to go with this also script plot. Right now I'm just not going with anything, so let's okay, and let me check. Okay, okay, so I'm just going with okay. Now the result is before us. So now we can see the KMO measures that the adequacy of the samples we just confirm with the help of this KMO value, that is 0.59. It is very close to 6, and it's above 0.5, it's also acceptable. And with this BTS, as you can see that significance value is also showing that the correlation is significant. So we are somewhere rejecting our null hypothesis that there is no correlation is there. Now the talking about this communality. See this communality. See all the values, we should ensure that the extraction value should be above 0.5 in all the cases. So here we are also, if we just go to this 30, so we can see that all these values are above 0.5. So one thing is there. One thing important component matrix. Okay, before to that, I'm just going to this script plot. See what this script plot help us. See, with this script plot, you can come to know actually where the changes, after which point the changes is not so much significant. As we can see that up to here, the major changes means up to 2 factors. So here the major changes is there, and you can just see the pattern of this script plot. So it is somewhere up to, we can say somewhere between 10 to 11. After that, the very negligible changes are there in the script plot, but up to 9 we may say that here you can say the moment of this curve, as you can see, it's very significant. So with this, actually whatever would be the number of variables are there, factors also get generated up to that. We have 30 variables in our this analysis set, so you can see that 30 factors it's showing. Okay, up to 30, but we cannot go for 30 factors, because there would be 30 factors together explaining the 100% of the total variance. But why we are considering, we are following the parsimony and all these AFA basic objective, that we should have a minimum number of factors explaining the maximum number of variance. So here with this script plot, it's a graphical representation. Here you can get an idea actually that it's very helpful when you are trying to fixing your factors, okay, that you are already fixing that how much you want to get. So we will talk about that only. Okay, so with this now KMO and this also this 0.59 and the significance value also you need to report. Yes, communality table also you can report, you should report in your results, these communalities. And total experience explained. So if we talk about this total experience, okay, total variance explained, that as you can see up to 10, your 71.68 percent of the variance has been explained by 10. But after 10, if you just see that their contribution is very negligible and very less. And you can see that up to 30 means up to 30, it's when we are including all these 30 factors, it's able to explain 100%. So if we just consider right now at this moment that up to 10 we are getting 71, and after in the remaining 20, it's just it decrease this 100 minus 70 or somewhere 38, around 38. So rest 20 factors there, if I'm including, it's just going to contribute up to 38%, and my initial 10 they are able to contribute up to 71%. So that is something we just consider in this. And very important, this component matrix. So when I was just talking about component matrix, and it is a matrix where your eigenvalue and that communality, you are able to calculate this value. Actually you gets calculated from here only. See, this is a statement, or you may say a variable. For each variables there are some values, okay, there are some values which is loaded negatively or maybe positively with a minor value or above. They are loaded in these 10 factors. And if we just go to the communality, we can see initially it has to be 1. So when we are considering all these 30 factors, because that value, it's quite possible that the value, definitely there would be whether minus or something. If we will include up to 30 factors, there would be some values here. If we include all these value, so what we do, the square root, the square of each this value, the sum of square of all these value, this means horizontally, row wise, if we go and calculate, we will get one initial value, this initial, that's why it's saying. But out of this initial, what our factors are able to contribute, it's points, I think 0.672. So when we do the square root, of this, of each of the value, and at this last we calculate it, all this 10 is value which is squared, then we will get this communality of 0.672. Now the second thing, if we just see total variance in this, you just see that initial eigenvalue, that is 6.610, this you can also get it from this, but all this we can get it the procedure is same. When you calculate square these values, each values, when you get the total of this value, you will get that value. So this is with regard to these basic things that we need to report. Now again, one thing, in factor analysis, okay, so extraction. So as I just said that this PCA method is used and secret plot we have seen. Now I'm just unchecking this. So here something by default also one that the eigenvalue 1 it's there, but one thing is there, you can also go with the fixed number of rotations. Fixed number of rotation, as I just said, that if someone is very much expertise and that person just have a specific specific reason why you that person has extracted 4 or 5. So now you can extract 5 factors also, and let's say continue. Okay. See, now you are able to get these 5 factors, but see the total explanation, as I just told you, as the number of factors reduce, the total variance also get reduced. So it's showing now 50%. It's just 50% your 5 factors are reduced. And importantly, one thing is there also, that your commonality value also gets down. See, it's 375, it's 0.473. So now the values are also affected. But that's why it is expertise is needed before selecting that, the fixing the rotation. So it's better to be keep this as per the eigenvalue. So this is we can do in this rotation. So in rotation, we can use, as I just told you, the varimax we can use, and it is highly recommended. Sometimes its iteration limit is 25. So sometimes we need to increase it rotation, because in rotation it needs different iteration process. It is a one process where each time the correlation matrix correlation gets calculated, and it's repeat till it achieves a same value. So in Excel we can also check that, but right now we are very much focused on SPSS. So right now the basic rotated component matrix is there, component matrix is there. One thing we can do, let's the values are very clumsy, and with the help of this, let's one thing we can do, that for better analyzation, what we can do, we just limit the, here the option is there in coefficient display. You can just limit the values which are below 0.4 or 3. So basically we keep 4, and most of the cases 1.3 as discussed is also recommended. At least it should be very close to 10%. So continue on. Okay. So here we can see that now my component matrix is there, and my rotated component matrix is there. See, now when I'm just going through this component matrix, that the distribution of the variance, see, cross loadings are more, as we have this much, this 30 data variables are there. If we have more than 30, so we will having more cross loading. See, the cross loadings are more here. Cross loading, here is the cross loading again, and you can see in the one number of factors gets loaded, number of variables gets loaded. And when we go to this rotated, see the distribution, it is little bit much better than the previous one, although some loadings will be there, but not as compared to that. The distribution of this variable is little bit changed, as you can see. Now they are not significantly maximum of that value loaded on the first as compared to the rotated. So that is here the advantage of using this varimax rotation. And we have one thing is more there that may helpful in for later analysis, that if we are going and we are just selecting the save as variable and regression, we are just checking it. So we'll be able to get continue. Okay. Okay. So in this in our data set, you can, after this going to the factor score, you will be able to get at the last you can see this factor 1, 2, 3. So each factors your independent variables, these are the standardized standardized factor value. Okay, this standard factor score are there. For each of the factor score is calculated. So now you have factor 1 to 10. See, these are factor scores, and that with this you can proceed as considering this as an independent variable in case of further analysis in regression. So here if you are just going and just checking at this uh, just with this option is there, no, this regression, so that factors gets, you will be able to get the factors in your data set, and you can use that as factor score, factor 1 2 3 for all the 10, whatever the factors will be there, it will be there, and you can use it for your uh, future analysis, for especially with the regression. So with this, if we talk about the key things that which always need to remember in this, that one is the KMO value, and this BTS significance level we need to report in the result, and this KMO value, this KMO value we need to remote for each of these. Second, this sorry commonalities value, this TVE actually total 10, how much it's contributing. Second is you can report to the rotated component in matrix if you have used a rotation also. And one thing is there, like in the case of this, when we have 10 factors, and when some loadings are, we may say that a few cross loading also there with regard to this statement, my after sale service provide service as promised. Okay, so you can see that here also 0.590 and 4.51 is there. So when we can only keep this statement in the factor where it is loaded with the higher factor loadings. So as discussed earlier, we can only keep that variables in that factor if in the case of it is loaded more than one factor. So the value with the higher factor loadings we can keep only to that factors. Same with the case of here also we can see, and yes, here also 0.491, 0.433. So we consider this statement should be in this, that is 1, 2, 3, 4, 5, 6. So it would be become a part of your 6 factors, and it will not be a part of 7 factor like that. So here, see here it is loaded a minus, and it is loaded 0.407. So we will consider this value and this. So one thing also we can, I think we can also do this, that we can, if we go to it, so if we want to see this, we have a chart editor also. You can also take the help of that. See whatever the tables you have, like earlier it was an on the row side there was a statement and variables, and on the column there would be a component. So with this, when you just double click on this output, the chart editor will be open, and with the help of this pivot you can transport rows into column. So it would help you to actually and identify that factor wise you are able to get the output, that in which factors what different variables are falling likewise. So if you wish to go for that, you can also use that, and if not, so you can again go to this transpose. Now you that your this output will again turn into a original view. So this is how we can think, and we can report number of things in this using EFA. So one very important thing is that your this use total variance. Yes, I report just when I just selection of factor analysis. So on the basis of a script plot, I just told you that with the help of a script plot, as I showed you, one may decide, okay, up to which changes is not negligible, we can give up to that factor. Second thing, total variance. If you wish to keep, okay, 71.686 factor, I just want it. So it's getting 10. Let's check, and if how much we are getting at 8. Okay. If I'm just fixing it 8, let's say how much I will be getting. See, earlier in the 10 cases, I will be getting 71. Now if I am fixing to 8, it's 64.55. So just dropping of two factors, just dropping of two factors, we are able to get 60, around somewhere 65% of the total variance. So it's up to you how much you are going to decide and what parameters you are deciding. If you're taking the total average variance as a base, so as in the social sciences, if it is 60% and more than that, it is sufficient and it is justifiable. So you can keep also, instead of 10 factors, you can keep to 8 also. So here you can just take this take this as a measure. Second measure, you can also adopt that on the basis of this eigenvalue, that up to 1 you can keep, it's okay. Second thing, your variances. So moreover, based on the prior information, based on the script plot, it's up to you. But if someone is fixing the factors, so make sure that you have a strong reason, and if some some justifiable reason is there, or the expertise is needed before fixing that. So in my view, if your data is quite new and you are developing a skill, basically it is for that purpose. But we have seen that in the number of papers, people also using on the skill which is already developed. So you can also go for, but ideally this is exploratory factor analysis should be applied in that case when we do not have already developed standard some skills. So reportings, I have already discussed that communality, TVE, KMO, and this, if you have taken a rotation, then rotated with each of these, each factors with these values should need to report factor analysis, that is factor loading. Second thing is, now you, with regard to the naming of this construct. So as you can see, what different types of statements are there. On the basis of that, you will decide that what should be the construct name should be given. Like it is related to the encouraged friend, considering of after sale service center, annual maintenance, okay, provide service as promised. So something related to the after sale service it is talking about. So in this, you can just take the name or decide the name of the construct based on this factor. And here this if you just go to the, it's this construct, see customer about phone calls, services, tells, so it's some sort of communication. After authorized service center remind customer about, reminders is there, customer phone calls is there, tells information is there. So see, all these things are there, so you can name them in terms of communication or some sort of things. So on the basis of these variables, how much they are likely are loaded, so we can name the factors. So with this, I think EFA part is completed using this SPSS. After that, quickly we will quickly go to this CFA. That is the next part of confirmatory factor analysis. So for the CFA, the data is already shared with the another file name. It is CFA. With the file name of CFA, it is shared. So you may get the CFA file. So we are now moving to the CFA. Dr. Asad, is it visible?
The slide is visible, yes.
Okay, thanks for confirming. Okay, so as in the beginning, we have talked about that the basic reason to use this EFA and this CFA. So as number of researchers have recommended, and also it is there in research methodology by usage of this EFA and CFA. So basically, we have seen that number of time even the skills are there and developed, and people have used EFA and then they have go for CFA. So as this name is there, that confirmatory. So here we are confirming something. So what we confirm? We only confirm that is something is there. Okay, so as we compare to this exploratory, that there we were just trying to explore the things, and here we are confirming something. So those who are developing the new scale specifically, so when they are done with the exploration part, now they should go for CFA, so that a confirmation should be there that whatever the scale is there, it is it's okay, it's valid or reliable or not, through different validity we will be talking about with this session. So confirmatory factor analysis, today we are going to talk about using software AMOS, analysis of moment of structure, and it is very highly used analysis in the field of social sciences. We have been especially in these days, in SEM also CFA, it's a measurement model part we talks about, but here we are very much limited to the just EFA and CFA. So with this confirmatory factor analysis, as I already said, that when the scale is already developed, some scale is pre-existing scale there, the theoretical information, the literature is available, the theory is there. So one should go, if someone is adopting that particular scale and that using, so one may go for this confirmatory factor analysis instead of going with the exploratory factor analysis, because something is already existing and just you are just confirming that whether it holds as it is and it was claimed by that other in a different context, or some changes are there. So basically we have seen number of papers on that talks about scale refinement also. Okay, so that things is scale refinement, scale purification, cross cultural scale comparison sort of things. When you go and search it, so then you will get a number of papers on this. So basically,
Sir, I have a question.
yes please.
Sir, myself Manish Shankar. Sir, if you say that when we will be before going for the SAM model, if we do confirmatory factor analysis, that means we have that scale through which we are gathering the data is already established scale, right?
Mhm.
And if we are going for EFA, that at that point of time means if we are performing EFA before the before going for the SAM model, and then we don't have our scale of gathering data, means standardized scale for gathering data. Is it the meaning what you are telling?
I'm just if what I am able to get you, that see, if the basic purpose of using this EFA and CFA, I'm not just telling that it is completely wrong. There are number of papers are available and it is published, but something we should be we have a mean median mode, all talks about averages, but sometimes others, but we do not use each thing in every cases. So there are some basic objectives behind that. So EFA, that the development of that EFA, the objective, the basic reason for behind that, to exploration. As name implies, if you go to, you can also refer to a book of given by Barbera, multivariate analysis, and there also in Sierra Kotari also. It's the basic purpose exploration, where we do not have idea that how much variables will be there and what items will be loaded on which factors. So we are exploring something. But when the scale is already there, I am using that scale. It means when I am just using that scale, it means I'm also know that which construct having which type, which number of and which variables will be given to that construct. Okay, that is already pre-decided. So when I'm using that scale in my context, so it is better to go for confirmatory, because already all the things that I'm just going to use, it is already been confirmed by someone else. Okay, it need not to explore something. Or maybe,
Okay, sir.
or
Okay.
maybe, please
Yes.
just give me a second. Or maybe if you are using EFA, suppose you are using that EFA, and if the response is insincere, if the response is insincere, then what will happen? Then it's quite possible that whatever the items were there which were loaded in different construct, it may completely change in this context. So in this, the sincerity of the response itself become a questionable in that case. Yes, please.
Okay, sir. Sir, then
Manishankar, could you please give me your email ID or mobile number, because I am not finding you in the recipient list.
yes, sir. I am sending you that, sir.
Yeah, please talk to me first, then you can please ask the questions.
Okay.
Okay. Uh,
Okay, sir. I'm done, sir. Yes, sir. You can continue.
Okay, thank you. Thanks. I hope I have answered the query. Okay, so we talked about the CFA. So we have talked about the CFA also. So let's move ahead. Let's learn something about CFA. Then also we go for the practice session. Data is already shared. Something. So CFA, the basic difference, if we talk about what are the distinctive features of CFA over EFA, that in the EFA, we are not sure that how many constructs will be there and what items do we get in each construct. That after the exploratory analysis, we only get that. But before going with the CFA, we know the items, we know the how many constructs are there, and we assign that items or variable to the CFA. So that is the basic difference that here we already. Again, moving ahead, so CFA is mainly conducted with the knowledge about how many factors really exist or which variables belong to which concept. As I just said, that the basic and the most important difference between EFA and CFA is this, that in EFA we are not unknown to what items, how many items will be to that loaded with that particular factors, and how many factors actually we are going to get. But CFA, it is already confirmed, and it is theory is there and model is there and previous work is there. That's why we are talking about this CFA. So CFA is applied to test the extent which a researcher a priori, as prior information is there, or theoretical pattern of factor loading on prescribed concept represent the actual data. The same thing that I just answered the query, that it's talk about your complete this CFA. Now, when we talk about the features of CFA, so in this, if we talk about now the factors, it is called as latent variables, and whatever the variables are termed as observed variable or indicators. We call these latent variables. We try to know the hidden things about on the basis of using some other statement. We cannot directly measure that construct. So with the help of these indicators, with the help of these variables, we are trying to uh, understand, or we're trying to get the value for that construct. So generally, as in that case, the case of cross-loading were there. In the case of EFA, cross-loading were there. But in the case of AMOS, hardly you will find the issue of cross-loading. So the cross-loading, it's also not a big issue in this. So if each indicator is represented as having two cause, a single factor. So with each indicator, there will be an error term, and there will be a arrow where we will discuss in the case of type of model. Then we will also get with that. Okay. So next, the measurement error terms are independent and of the factors. Yes, with each of these indicators, the variables, the observed variable, there one error term is always associated, which is unexplained. And all association between factors are analysis. So whatever the factors are analysis, we will try to analyze with the help of covariances. So the key differences that always most of the times we are very much confused, and we are don't know actually what basic difference between the EFA and CFA. So just with this quick key differences that I have pointed out here, it is helpful in validating a measurement theory with the CFA. Yes, thing is there, some pre-existing model is there, and somewhere our in our work, and somewhere we are trying to check it and validate it with the help of CFA in our context. Okay, then with regard to EFA, so it helps in proposing a measurement model. So before, if something is new, the model is new, the theory is new. So before CFA, we go for EFA to explore the thing, and then we just validate the thing with the help of CFA. So cross-loading, as in this CFA, we know that already the items are known, and this the loading, cross-loading, there is no chance of cross-loading. The cross-loading mostly basically fixed at 0. But in the previous exercise, we have seen that EFA model involve cross-loadings. So in CFA, one thing is there, that whatever the errors are there, means the error term, which each we will see the when we have a CFA measurement model. So the error terms, there may be a chances of correlation between error terms of each variables corresponding to that particular factor. But in EFA, error term assumed to be uncorrelated. It is assumed, not in practical situation it is there, but it is assumed. Okay, because in social sciences it's very difficult that one thing is completely not associated in some way. So in CFA there are theoretical restriction that in this CFA we have seen that theoretical previous theory and some it's needed, but in EFA assumption, let us identify the model. So some assumptions on the basis of total variances, scree plot, or maybe the eigenvalue, we are able to get some model with some factor loadings corresponding to each of the factors. So measurement theory, CFA cannot be conducted without a measurement theory. Yes, as I told you, so CFA, we must have a pre-existing work or theory if we are going with CFA, because we have to assign to each factor some variables. Then why we are assigning some variables to that respective factor, we must know this. And with regard to EFA, as I just told you, it is a beginning work, it is exploration work. So theory is not needed to drive this factor. So assigning variables, as in the very beginning of this CFA start, when I was just about to start that CFA, so I just told you that in this researcher assign variables to factor before the result is obtained. Before running the CFA, we will also go and check this. So we will assign variables to each of these factors. Then only we can go and run this confirmatory factor analysis. But with regard to this EFA, a statistical technique assign variable to factor. So in this EFA, with the help of method, with the help of rotation, we are able to extract that particular, this factor exploration is there. Then our exploration model will be available. So just moving ahead. So measurement theory. So a measure is used to specify how set of measured item represents set of construct involved in a theoretical model. So it's a talk about completely related to the theory aspect, that what different construct are there, what would be the number of construct, how each construct carries what number of these variables. So measurement theory, it's work on a measurement theory, and it is with a relationship that suggests how measured variables represent latent construct that is not measured directly. So as I already said, that it helps to identify that latent variables, that the factor, or you may say a dimensions, how it is being measured, not directly, but with the help of some variables. You may call it as the indicator. Sometimes also it is we call it as an item also. With the help of this, how we are going to do this. So the measurement theory may then be combined with the structural theory to explain a SEM model. So as before to the SEM, we always go to in the AMOS, we go for a CFA part, so that confirm the model fitness. If model fitness is there, is our if fit indices are met the threshold level, then we find it useful, we find it meaningful to move for that SEM. So measurement theory validation, defining individual construct, as I just told you in the case of that every construct we need to define, and we need to specify the items to each construct. And in case of lack of availability of previously developed, the researcher may have to develop a new skill. As I already told you, that in that case, when the theory is not there, so before going to CFA, you need to develop your skill. So unidimensionally also, it's important nature that unidimensionality, it should be there, that only the items should be loaded in one construct also. So that unidimensionality that was explored in EFA gets confirmed here, that whether it is confirming or not. And sometimes it's happened that in explorative analysis a factor 1 loaded with 8 or 7 and when we just DFA as it is advantage, it's a better experience. So we have seen that we are left with just 5 variables to that factors. We also seen that dropping of items we have find here in CFA also. And as I said that all cross loading are hypothesized to be 0. So something called as congeneric and non-congeneric model, it is something just for our understanding. Suppose as though it's not exist, but if sometimes some relationship is there and someone try to just develop these things, so it will consider non-congeneric. So non-congeneric is the situation where someone is trying to this with the double-headed arrow try to just link these two error term of a same construct, maybe some error term of two different construct, and sometimes as you can say that one this indicator also associated with other. That is ideally not to be the in the CFA part, but some people that don't, when they do not consider these things, so they just consider a part of this, so it should be avoided. So the thing is now with regard to CFA, reflective and versus formative construct. So as in the CFA, all the this work is related to the identification of construct, then construct validity and scale validity and this discriminant validity. So it should be very important that construct should there. Okay, we talk about construct, and in terms of AMOS, basically reflective theory, its work, which based on the idea that the latent construct cause the measurement variable, and the error is an inability to fully explain this measure. Just try to understand with this. So when we have reflective model, so here this timeliness, okay, timeliness constitute all these. Try to explain x1, x2, x3. Okay, here this timeliness is to explain these things. So from this exogenous, we also called as exogenous variable, or better when we do not have a same, we call it as a latent variable. So these timeliness, see timeliness, what is just, we just take an example of three, that someone who just uh, follow our timeliness, so definitely accommodate last minute request also. Punctuality, it will be found in punctuality in meeting deadline, and speed of returning phone calls. Okay, so all these can be indicators, and those who are following a timeliness, that these things can be explained by this timeliness. So here we can see that reflective model is there. This timeliness is explaining all these three. And the one second important thing, that as per the Kulan 1998, the correlation between x1, x2, and x3 should be there, and these must be highly correlated. That's why they have form a part of this construct. But in this case of formative, this the situation is just this. So here from the observed indicators, the was recent accident can be one of that thing that actually impacting leading to a life stress. So here the arrow, single arrow movement is from the indicators, or you can say from the observed variable to the latent variable. So but, and second most thing, that indicators may have a positive, negative, even they can be uncorrelated. So the reflective and formative, basically in AMOS we work with reflective. So now the designing study for empirical results, how we are designing. So here the researcher measurement theory will be tested. Now whatever the theory is there, whatever the model is there, now it needs to be tested. So all the standard rule related descriptives is applied, like missing data should be avoided, and multivariate normality. So as someone is wishing to go for applying of SEM, so some analyses are little sensitive with this sample data. So with someone is wishing to go for SEM like that, so we have seen that the data should be adequate your result, affect. So someone has suggested 5 500 data, one has a 300 data. But generally we follow that number of items into whatever the number of items related to the 20 suggested, that if you have a 15 items in your skills, so you should approach to at least 20, means 300 respondents you should generate. Some have suggested with 10 also. It's depend upon the number of that variables, and also if it related to the customer point of view, so larger the ratio would help you to just get the exact result. If it in case of B2B, sometimes few researchers have also suggested that if we follow a proportion of 1:5 also, they can also work. Okay, so it may change a little bit with the context in which we are going to collect the data. So if we are done with the measurement model, we have tested the measurement model, so we can go with that thing. So measurement scale in CFA consider reflective indicators. I just told you, measure within all the better scales we can use, means interval and ratio. And all the indicators for a concept need to be same scale, but if better. So sometimes it is also advisable that whatever the indicators are there, it should be taken on the same scale. So assessing measurement model validity. Now the key things that what things we should consider, and how we can ensure the model validity, and what indices do we have to consider and report. So first thing, assessing fitness of this. So in this number of CMIN by DF, that is the chi-square divided by degree of freedoms values there, which is always reported. I will also show you. And some fit indices also recommended by here and others in his book, that GFI, goodness of fit indices, NFI, norm fit indices, CFI, TLI. So alag different indices are given, that it is already by default you will get it when you execute and run a particular that CFA. So these are goodness of fit, and there is one also indicators that badness of fit also there. So one thing is there, we will need to report this. Then path estimate. When testing a measurement model, the researcher should expect to find relative high loading. So basically high loading is expected in CFA, that above 0 point is satisfactory, but we keep at it should not be less than 0.04 0.4, because in the terms of when we go for validity also, so there we may face a problem of calculating AVE and discriminality and mergeability. And estimation, we also need to check the estimate. When I will just execute the same, we also go with the estimate whether the items with regard to that construct they are significant or not. We can also, if it is not, then we can drop it. Or if it is poorly loaded, then we can also drop it. That's why in the case of scale purification, when some researcher work on scale purification, then these things happen.
Sir, I have a small question.
Yes, please.
Sir, is it mandatory that during reflective model we have to go for EFA? Is it something means standardized like that?
Peter, we are. I think we are talking about the CFA, not EFA, and
No. Yeah.
if we are working on analysis of moment of a structure, so reflective, most of the time reflective cases are there. It's totally work on reflective cases. And if suppose if different situations there for second order factor, we can also go for, in that case that we find that what our construct is confirmed, and it may represent to a new construct, we can represent with another construct. We can also use that. So I just when I will just go with the diagram and just run with the CFA, then I can also discuss that part.
Okay, sir. Okay, sir.
Okay, thanks. So something we must ensure in this, because now whatever you have explored, it is now going to be confirmed. Now for confirming something, we need to validate also. So for validity, we need something. What one content validity, also known as face validity. It's just nothing. It's just basic. It's a subjective thing that with the help of experts or in that field, or maybe sometimes we go for our professors also in university, that whatever, it's just a subjective thing that the enough or not. Is okay, then you can go for. Convergent validity means try to just understand that convergence means whether all these statements are actually converge to a particular factors or not. It is related to the construct validity. So the specific construct should converge a high proportion of variance is common, but whatever these variables are there, all they are converging to that particular factor or not, we try to get that. Then something called as average variance explained. So average variance explained is nothing but the square root of the factor loading, which is the correlation, and when we get a square root of that square, that is the become r square. Then what we do, we just sum up that r square, we will divide it with the total, that is a summation of that square of that what to say, r square plus the error term which is left to be explained. Then I will show you also how to calculate it. There's something called as composite reliability. Also, it need to be ensured, and it is related to that part, construct validity also, and it is minor changes is there in terms of its calculation, and it is also reported for this composite reliability. Also, it is related to an indicator that we use. Now, discriminant validity, which believes that the identified indicator, the identified factors are sufficiently differentiate among, means no correlation if they are sufficiently not related. So in basically, if we talk about, so it is not possible that 100% or completely they should be they should not be related, but some relation should be there. So it believed, it's assumed that this, with the help of discriminant validity, we try to find out that this how these factors, these identified factors are a little bit uncorrelated or least correlated among each other. Now we could talk about some zero order, second order, third order, or first order. So now moving ahead, now you can use your data set what is shared through mail with the name of CFA file. So I'm just going to open my data, CFA file data. It may take few seconds. So I hope you can view my.
Yes, yes, it's fine.
Yes, I hope that participants are now ready with the data file with the name of CFA practice file.
Participants, please respond.
Yes, sir.
Okay, thanks for confirming. See, the moment we just to open this our you can see CFA, for just CFA, when we open this software AMOS. So this white, the thing, the platform you are getting, canvas we are getting. So in this, if you want to change, I'm just little bit discussing some key things related to it, that most of the time I use it as per my requirement. So the size of this canvas you can change and select as per your requirement. A6, A4, A5, these things are there. You can also check it work as just a page setting that we used to say. So right now I'm just if I'm just selecting A4 size, okay. So right now I have selected that. Now my canvas is ready. So one thing is there that you can just simply go and collect, just click this and just pressing this left key and just move little bit. So the circle will be created. The circle will be created. I am repeating again that you just need to go and click this latent variable to draw a latent variable and add an indicator. You just click it once and you just come to this, it will get selected, and just pressing your left key of your laptop, just sorry, remove this indicator and keep the size not too big. This much is sufficient. So with this you can draw your latent variable. Now as I just told you that in CFA we know that how many items or we may say an object variable are associated with each of the construct. So here you can just keep, see, this turns into red, means it is activated. Whatever you will do, it will just perform on this circle, this latent variable. So now it's turned red, so I just click once. See, one item is added. If I just I'm sure, so whatever data is there, 12 item is there, so I know that the item with A, F and D, there will be a 3 factors is there, and all these A will be loaded in 1 factor, F will be a part of 2nd factor, or D will be a part of the 3rd factor. So I need 4 for my these 4 indicators I want for this. So 1, 2, 3, 4. Now it is ready, and to keep it in a proper shape, proper structure, what I can do, I can just again go and unselect it, and now I will try to select this, rotate the indicators. Now with this, the moment I just click it, it will get activated. As you can see, now I can rotate these indicators. Now if you wish to keep it here, you wish to keep it here, or you wish to keep it here, you can move this as per your requirement. So as I know, as I already know that I want 3 factors are there, and each factor consists of these 4. Each factor consists of 4 these 4 indicators. So right now what I can do, to just to save the time, what I can do, I can also go and copy. See, here you can just duplicate objects is there, tool is there, duplicate object. I can just select it and I just get a copy of this. Okay, something wrong. I need to do this. What happened? Okay, with this I can get a copy of this. No, there is some mistake is there, I think. Select all, select an object at a time. No, deselect all. It is simply a copy. There is some error in this, I think. Otherwise it can easily get copied. What is the issue? Okay, let me try it again. Okay, so there is option. I don't know that I'm just forgetting something. So you can just copy it. So right now I'm just going to draw separately 4. Again, it's not working. So 1, 2, 3, 4. Now again I will do this. So right now here you can just how how you can just make this 3, as we required 3 factors, and now we are done with this factor. So my latent variables and these indicators, I'm ready with this 0 factor. So in this, what I need next, so I need to select a data file. I need to select a data file. So what I can do, there is a slide here, you can see the data file, and file name, it's asking for file name. So make sure that wherever you have downloaded, you can select it. So my file, it has this desktop, so I'm using this CFA practice file. Okay, so once you have selected the file, you can also view data, that is it the same file or not. Okay, so when it is done, go back to this and check it. Now here list variables in data sets are there. Okay, now whatever the variables are there, you can just find these all these variables there, and now you need to put that variable select for each of these observed variables. So as I just said that I have selected uh, a for these, so I'm just selecting this because the label is there. You can also uncheck the label there in your SPSS file if you are just going to delete that. So you can simply write a1 a2 in that, and we can also do from here also. We can just erase this also from here. It not just take few more seconds. So now I have selected indicators for my object variables. So now the moment I just click it twice, it's get activated, and from here I can remove this variable label here. Again, one by one I can remove all these, so it will become more I just want a name, not label. So label I'm just removing from here also. For second, I'm just using F.
Sir, you can go to view interface properties in miscellaneous and take the label. So view interface properties, miscellaneous, MISC. In that, untick the display variable labels.
Okay, okay, okay. Yes, I got it. Thanks. So I need AF and I need D also for this. So now the variables are there, and I also giving a name of some name is there. Let's say F1 is there. Let's say F2 is there, and let's say F3 is there. And from plugins, now I can go to name unobserved variables. So whatever the errors are there, I need to also name them. And we have done with this. Now the next thing is we need to draw a covariance between each. Okay, so whatever the factors are there, we need to also check the model fitness. So we are with the help of this covariance, we are trying to find out the covariance between these uh, variables, between this construct, and also considering a complete model, so that we can go for check model fitness. So with this sticks, we can just make it a little bit better up here. Okay, now we have done almost our model is ready. So what we can do, we can also check, go to the analyze properties. Right now we want maximum likelihood level in this, and nothing we want. If we want a standardized estimate also, okay, and let's calculate estimate. I think everything is fine. Okay, what issue is there? I think every is fine. What is the case? Okay. F1, okay. So it will work. It will make a problem. Okay, so now it's done. The process is done. Earlier there was a problem. It need to be saved the place, and second the name should be not same. So with this we can go and we can check our output also. Now you can see we are ready with the loadings also. It is there. So basically these are the factor loadings for each of these indicators to the respective construct, and move parameters. So if this parameters is hidden, so we can just move it little bit. Yeah, if we can make it also clear. So here the main thing is there. We can right now the model is there. We need to see few key things here. We need to see a few key there, that is factor loadings. These factor loadings is very important, that how with these loadings are loaded on this particular construct. And already if we go, and this is the r square. Okay, that is the r square of this, the square root of this r, it become a r square. So now the main purpose of this to check the validity. So in this from this construct, we need to find out the two important thing, that is the model fitness. Then for that we can go to this view text part. So here the estimate that we talked about, that whatever the we have to check whether all these are significant or not. Then critical ratio is just when you divide this by this, you will get this critical ratio. Second important thing is model fitness, that we report in our CFA, that is the CMN by DF. So if it is near to 3 or less than 3, it's good. Even sometimes 5 or 6 is considerable. One thing that we always try to look this. So if we suppose we, as we are working on CFA also, the CFA, that we believe that the theory is also there and it is already pre-existing. So if we are able to contribute something, if our CMN DF get decreased as compared to the previous one, then we can expect that some contribution is there. So that is one of the key indicators. So there are some goodness of it indicators also suggested, that GFI, CFI, and NFI norm by different scholars, that if model is good, then how much it has to be good. To be above 9.9 means 90% or 95% you are getting, it's great. But in some cases 0.85 also some researcher have suggested, but it has to be above 0.9. And if our model is bad, like if this model is bad, so how much we are allowing that this model can be acceptable. So there is a root mean square, we can just also consider that it is 0.084. So less than 0.10 it's also acceptable, but the measure of the researcher is suggested that it has to be less than 0.8. So it is very close to 8. So we can expect that the model is somewhat it's just a fictitious data I'm working on, so it is close to a good fit. But as CFI is 0.877, so it has to be above 9. So we can improve it through that our uh, data quality, and with the number of more inclusion of more that data set, new respondent. So with regard to the ensure the two things are left, that conversion validity and the discriminant validity. So with regard to this this conversion validity, we need average variance explained. So variance explained is nothing, that it is the square root of this, then we will calculate 0.17. Like if you go to the here, that's why I just skipped at that time. See, so these are the factor loadings for each. Let's say 3 items are there in this, as we have 4. So these first one, are the factor loadings, and these are the square root of that. So the formula is lambda square upon lambda square plus error also. So in this you can see when the square that is already it is there, we need not to calculate. It's when you just click a squared correlation in the parameters beside analysis properties, it gets calculated. So 0.17, 0.34, 0.55, 0.40, it's become a part of this. It's get calculated and it will be divided by what? The sum of the square, and which is unexplained, means 36 means 36% of something explained, that is the r square, and which is not explained, it is considered to be an error. So summation of error plus summation of r square, when we divide this we will get AVE. So AVE should be greater than 0.5, not below 0.5 is acceptable, one thing. And second thing is that compositive reliability we need to also check. So CR we need that need to be 0.17, sorry 0.7 actually we need it. So here we can use it, but the slight changes is there. Earlier we were using this summation of r square, but this time we need that summation of this factor loadings and divided by this factor loading plus error. Now we are not considering this time the squared sum of factor loading, that is r square, but we are submitting this summation of these factor loadings, then that square divided by this plus error. So we will get this composite reliability which has to be above 0.7. So with this conversion validity can be ensured. With regard to this construct validity, so one approach is there that interconstruct correlation, that is the interconstruct correlation, the AVE should be greater than the squared construct correlation. So whatever the correlation is between each construct, their square root should be the squared should be less than this AVE. Second approach is this, that you can also go with the help of this AVE and AVSV, average shared variance and mean shared variance with this. So with this MSV and ASV you can calculate, and in each case it should be less than your AVE, that is 0.5. So with regard to this MSV, we will consider for each factor which is the highest value and the square root of that. So if we are calculating MSV for this factor, so 0.66, and for this 0.63, and for this 0.66. So MSV will be calculated the square root of this, that is we calculated 0.36. 0.36 will be there. So 0.36 has to be, which is less than that 0.5. Definitely AVE need to be 0.5 and it is less than the 0.5. So MSV need to consider. Then ASV, what we can do, we just select for this factor, this and this, as two arrows are there, 0.6, 0.6, this is there. We will plus it, sum this, divide by 2 as 2 are there, and then we will square that value. Okay, then ASV we will get that also need to be less than your AV. So if all your ASV and MSV value you are getting less than 0.5, so we can conclude that your discriminant validity it holds. And with this interconstruct correlation that I have showed you, this also mostly used by the researcher. So basically these reportings are there with regard to this this in the case of CHA.
Sir, can you please see the time?
Yes, so that's why I just summarize the thing, and because the other speakers will also be in queue and they need to start also. So with this, I have discussed this model validation and almost done it is. And if you can just, if from my side it's over, and if any query is there, so we can take query.
Anyone?
Sir, to get it,
Yes, please
sir,
ask.
you can, yeah. Sir, can you refer some good book from where we can get some details of this indicated?
Yes, at the basic level, you can refer to a research methodology by C.R. Kothari, latest edition. And second, one book is from multivariate analysis by the writer is Barbara and others. You can go with that. It's very detailed book. And for Andy Field, a book written by this, statistics on by Andy Field, it's also very useful. And one Indian writers, like if you just want to know the execution part, how you are going to execute, so data analysis using SPSS by Dr. Lokesh Jasrai, it's also available on the Amazon, and it's very limited. It's talk about very limited, just for the, if very much a person interested to use that, how to just go for factor analysis and other statistics also. Application part is there, but it is not too much in detail. But if you are going for CR Kothari, Indian writer, another one is there. In foreign writer, you are going for multivariate analysis. Here's one of the best book is there, Andy Field. So that is sufficient for you to refer if you are referring to that books. And I will also at the end, I will share few of the good papers with Dr. Asad and Dr. Jamshed sir. And they will just share it with you. It will be helpful to you with regard to CFA and EFA particularly, and with regard to scale development also. You may find it very useful.
Okay, sir. Okay, sir.
Any other question, participants?
Good morning, Dr. Nasir sir.
Good morning, sir.
Sir, actually I have a question. The question is, suppose the endogenous and exogenous variables have different sample size. How to run on structure equation modeling
Okay, sir.
when they have a different sample size?
Basically, sir, although the same is not part of my session, but you have asked the same part. So basically, if we go to the AMOS, so normality we need to ensure. The data normality also we need to consider in that part. But we are going for the smart PLS. That's why in this PLS we are using, where normality need not to be considered. Then most probably you go for that PLS part. And with regard to difference of this sample size, so some from, I don't know, means if the sample is adequate in both the cases, then I don't think there would be some problem or issue with regard to this analysis. But in that case, you prefer to run on PLSM.
Yes, SSCM. Okay, sir. Okay, sir.
Sir, what about EFA? Does normal distribution play a role here in applying EFA in SPSS?
You are talking about EFA?
Yes, sir. In EFA, like if we are planning to do EFA, we are concerned about the sample size. But what about normal distribution? Is it important here?
Important. That's yes. We if we are getting a normality of the data, then it's wonderful. And in the case of ratio data, if we are working on EFA taking the ratio data, then it is you can also check, but the outlier must be checked in that case, outlier, because one extreme value may affect your overall process. It may affect your others value also. That we have seen also when we just try to fix the factor also. We have seen that how the communality values of different indicators get affected. So these things, if we are ensured in previous before going to execution, so it may help to get a fruitful and best fit model through a EFA or CFA.
Thank you, sir. One more question, sir, please.
Yeah.
If I am working on secondary data, like if I have counted few variables from reports and like financial data and anything, and I need to find if they are correlated or not, I need to explore and find some variables in this data. Is EFA here possible, or it should be only primary data?
No, see, if you are working on means data is already available, and you most probably you are working on finance, so you need to see the data, and you should go for instead of EFA, you go for a CFA in that, and try to use that rotation with Marimax. Oblique, avoid using oblique. In that case, you may get a better result, and you can confirm that.
Thank you, sir. Thank you, sir, very much.
Thank you. So, Dr. Asad,
Jaya, can you conclude the session?
Conclusion.
Dr. Jay.
Thank you very much, Dr. Mohd Nasir, for this beneficial and crisp session and for clarifying all the doubts, all the queries raised by the participants. I congratulate all the participants for their participation. I'm sure it will be effective in future for practical application of SPSS and AMOS in different domains. Now I request organizers to send feedback link in chat box, please. For you all, the link will be operated and open for next 10 minutes. Please fill the feedback form in time. We all meet at 11:15 a.m. for our second session of the day, Measurement Model and Path Analysis on AMOS by Dr. Vikas Kumar. Now, I, Jaya Madhurima, on behalf of Department of Management, SMBS, Jamia Hamdard, in collaboration with AICTE ATAL, announce that first session of today's FGP is concluded successfully. Thank you all. See you at 11:15 a.m. Don't forget to fill the feedback form. Thank you once again. See you soon.
Okay, thank you very much, all the participants, and for your patience throughout the session, and also a very humble and sincere thanks to Dr. Asad and Dr. Jamshed for this throughout this session, and helping us to just execute this session in a very smooth and